Hello, everyone. I am Chuck Singh, and I'm here to talk to you about three fascinating geological and geographic features around the world. These are all geographical features and geological features that I think do a great job of illustrating what we learned in Module 6, specifically regarding volcanism, plate tectonics, and the movement of everything within the mantle and everything above it. Let's start off with the Mascarene Plateau. The Mascarene Plateau is the name given to an elevated area in the Indian Ocean. Let's start off with Seychelles among them. Seychelles is an island nation here in the Indian Ocean, and it consists of a variety of islands, all within relative proximity to each other. Now, why is that? Well, to get a clue for that. Let's fly to Mahe, the largest of the island in the Seychelles. And most people think of beaches when I say Seychelles, but as you can see here, this is a very mountainous area. I mean, there are plenty of beaches, but this is a very mountainous area. So what could be going on here? Well, why don't we fly to the edge of this plateau to see what's going on? Now we can see that this is a raised area. This is absolutely a raised area that has plenty of evidence and obvious data showing that it's a raised portion of the seafloor. We're right here, right about here right now. Let's fly into the next feature of the Mascarene Plateau. Now, this rock bed has been mined specifically in this area and analyzed. And what they found was that this rock bed consists of raised igneous rock and granite seabed that is very typical of volcanic formations. Now, what's going on here? Where's the volcanoes? Especially if there was one in the middle of the sign, well, where'd it go? What was here? Well, let's head over to what I call Limestone Island. Couldn't find a name for it that was agreed upon. But the reason it's called Limestone Island is because this island has a particular history of limestone outcroppings and mining limestone. What could possibly be going on? Well, let's get another clue. Let's fly out to Mauritius. One of the most fascinating parts of the Mascarene Plateau, partially because of its history, and partially because that's where the dodo is from. We wipe these birds out. I'm very sad about it. But that's not what you're here to learn about. You're here to learn about this island, which also displays many raised igneous features. All the rocks here are volcanic in origin. We go on and follow this chain of islands away from the land where the dodo went extinct to the island of Réunion in overseas territory of France. Well, this is the final piece of the puzzle. This is an island very similar to Mauritius, a lot larger than most of the islands of the Seychelles, including Mahe. And that's because it's a lot newer. As you can see from the sharpness of its features, this is not an island that has extensively been weathered for a very long time, unlike Seychelles over here, which, for Seychelles, it used to be just as big, it used to be just as massive, but is now left down to this over weathering. And we'll get another hint of why that's going on. Let's fly over here to, no, not the Pleasant Village in the middle of the volcano. The fact this is an ancient and now dormant volcano. You can see evidence of quite a few large eruptions from this area. And then we move on over to the final piece of the puzzle. The active volcano of Réunion. Piton de la Fournaise, peak of the furnace. It has erupted repeatedly in recent years with multiple craters from recent eruptions, relatively recent eruptions, and it's continuing to add on to land here. Tephra here regularly accumulates and adds to the landmass. As you can see here, this is very young land, very, very recent in terms of geological time, and that's why it hasn't weathered down yet. So when you zoom out at the entire Mascarene Plateau, it becomes very, very obvious how the processes of volcanism that got us here are still continuing and how they might continue in the future. So what's going on here is that underneath the island of Réunion, underneath this volcano, is something called the Réunion hotspot. And that hotspot is a particularly thin layer of the crust where the mantle often likes to send out magma and has continuously done so for a very long time, and it looks like it's going to continue. It's not showing any signs of slowing down. But whether it be this active volcano on Réunion, whether it be this dormant volcano on Réunion with a very pleasant village inside of it, Whether it be Mauritius, once home to dodos, but now home to a fascinating tourist industry as well as mining, which is to be expected, very rich agriculture as well. To the granite mines of the middle of the Indian Ocean. All of this is more evidence for the volcanism that's every day all around us in our world, present from here to here. I hope you brought your winter coats because we are now in Churchill, Canada. Look at this beautiful view. But no, that is not why we're here. We're here to talk about the Canadian Shield, also known as the Laurentian Shield. It's a bit about 1.25 gigaannum old, so that's a very, very long time. So we'll fly to the shield boundaries here, all the way in the middle of Canada. And as you can see, the Canadian Shield is actually exposed Precambrian rock, specifically igneous rock, of volcanic in origin, that quite simply has not given way to ample topsoil the way much of the rest of the North American plate has, the North American craton, which has remained relatively stable for a very, very long time in geological time. Moving across here, you'll notice that this region of Canada isn't very populated, and that's because exposed Precambrian rock, both granite and igneous, isn't very good for farming. It's not very good for high density development. And to give you an idea of what that looks like, let's go to Flin Flon, Manitoba. Flin Flon, Manitoba is absolutely beautiful. If you look into it, you'll notice that there are a lot of trees, absolutely, but these are trees that are mainly not your long-term softwoods. These are mainly very hardy woods that spring up in areas where the soil isn't necessarily free of depletion or isn't necessarily able to nourish large forests of the type that you would find at a comparable latitude elsewhere. Now we'll move on to the town of Dongola, also in Canada, right over here, all the way on the other side. I know the Canadian Shield is huge, so why is this town interesting? Well, it's got sparse farmland, just a little bit of farmland. But if you look at the surrounding areas, there are a lot of people here. There are quite a few people nearby to here. What's going on? Well, as you can see in this picture here, the rock that comes up in Dongola and the surrounding Kawartha Lakes region is granite in origin. It comes from volcanoes and the process of sedimentary compaction as well. Tephra is compacted over time, and igneous rock is also present in a way that just isn't conducive to farming. To move on, we are going to go to Manila. No, not that Manila. This is the other Manila. And this is an even more striking example. This is a town not very far away, but it's surrounded by farms. There's farmlands everywhere here. The geology is just simply different. Now, what do we see here? What we see just south of Manila is a massive amount of population. In fact, the locus of Canada's population is largely to the south here, this being primarily because of the influence of the Canadian Shield or the Laurentian Shield. This shield makes it so that large portions of northern Ontario and Quebec, Manitoba as well, are just simply not suitable for expanded human settlement. They're not able to sustain life on large scale as far as farming goes. And generally, when cities do exist in this region, they serve to cater to specific industries. But don't worry, I have something really nice to show you guys. Something really nice. This is Perry Sound, and you can find some really, really nice out here. No, don't worry, it's not just puns. Because now we're going to go to Georgian Bay, Ontario, and I have something else really cool to show you. Some really cool shit you can see around here. I absolutely recommend that you go check it out if you can. So let's fly back to Churchill, and we'll see what the Canadian Shield really looks like. Now we're back here in Churchill, Canada, but it's not all doom and gloom. Just because you can't farm here doesn't mean it isn't awesome, because just look how beautiful this is. It might not be great for human settlement, but it sure is fascinating. And welcome to our final area, the island of Java within Indonesia. One of the most densely populated regions on Earth, Java has a fascinating blend of volcanism and fertility that continues to support a large population, albeit one with a careful eye towards steaming volcanoes. Now, Surabaya is a very large city. The metro area is over 10.5 million people, and you can see how sprawling this metropolis is. And one thing that I want to show you that really illustrates the points I'm about to make is this awesome bridge. And I promise it's not just because I like bridges. This bridge was built to not protect against completely, but at least mitigate the impact of earthquakes, tsunamis, and just the things that come along with volcanism, such as ash, tephra, silica spray. I mean, things that can really occlude vision. And all this had to be considered when designing this bridge over the littoral ocean to the island of Madura. So what sustains these 10.5 million people? How do we have a city of this size on such a small island and so many more like it? Well, let's fly over to some farmland. This is incredibly productive farmland nourished by a very, very long period of volcanic activity, introducing silicates, introducing tephra, introducing all sorts of a very fertile nitrates, phosphates, many different things that help crops grow simply better, to the point where Indonesia is one of the regions of the world, specifically Java, where agricultural productivity is so high that relatively small plots of land can sustain incredibly large amounts of people, especially since rice is especially calorically dense and able to be grown in a very dense nature here. And the source of all of this fertility isn't some ancient volcanoes either. These are modern volcanoes that still continue to exhibit activity. This is Mount Sumbing, which is wild to see in this picture. That there's an active volcano just in the background here of some active farmland. But no, that's actually a lot of Java. And if you look at this dominating stratovolcano that towers over the surrounding landscape, you're going to see that there's a lot of towns around it. In fact, even where the land isn't flat, in this area, you'll notice terraced farms that are stacked and layered to allow mountainside farming to happen. That's how incredibly productive the farmland is here, is that the sides of these mountains, not generally areas considered to be highly productive, are able to be farmed just from the fertility from the output of the volcanoes. And now we'll move on to Gunung Raung, meaning Mount Raung, and it's a fascinating feature because it is a very active volcano. It has been active consistently for several centuries now, and has had a recent eruption as soon as 2014 and 15 that shut down air traffic to the nearby island of Bali as well as to Surabaya. This area is, quite frankly, bar none, one of the most fertile in the world, because currently there is a volcano that is adding more fertility to the land as it progresses. And in order to show that, let's look at this small town here, where a tobacco plantation has been set up, as well as tree plantations, in the shadow of an active and not all that comforting supervolcano or stratovolcano. This just goes to show you not only the duality of life and other such things, but also just the importance of volcanism and of the process of hotspots is to human civilization, where humans settle, and also just the formation of a lot of these islands in general. If you follow Java, you'll see that the volcanoes, actually the oldest volcanoes, are over here, and this hotspot has not shifted, but the continental crust over it has, to the point of creating new volcanoes all across the island, with the newest ones being towards the east. And I think that is just awesome.